Imagine you are a developer, right? And you're tasked with refactoring this massive, complex legacy code base. You sit down at your desk, pull up your terminal, and then you do something that feels, well, completely counterintuitive.
Yeah.
You intentionally close your web browser.
Right, you just shut down the graphical interfaces entirely.
Exactly. You isolate yourself completely in a text-based command line. And by doing that in an era where we are, constantly surrounded by incredibly advanced AI coding assistants, you actually manage to triple your throughput.
I mean, it seems totally backwards on the surface. We've spent, the last decade building these beautiful, comprehensive dashboards and unified web IDEs.
Yeah.
But there is a very specific, undeniable logic to stripping all of that away. Especially, and this is key, when you factor in the sheer volume of code that AI can generate today.
And that tension, right, between the lightning speed of modern AI generation and the necessity of this austere text-based control is exactly the core of what we're unpacking in this deep dive for you today.
It's such a fascinating topic.
It really is. So our mission is to dissect a really intriguing presentation from 2026. It's by a developer who goes by the handle at Luck036, and it's called the Open Source Dev Flow. Git, GitHub CLI, and CI.
And honestly, while that sounds like a highly technical toolkit just for programmers, there's this massive twist to it.
Right, the AI angle.
Exactly. The central thesis revolves around this idea of the AI paradox. We tend to assume that because AI can, write boilerplate Saffold applications, architect complex logic at warp speed, that the traditional manual constraints of software development should just fade away.
Like we don't need the old tools anymore because the AI does the heavy lifting.
Right. But the reality is the absolute inverse. The more you rely on AI to generate code, the more rigidly you actually depend on strict version control and automated testing to manage the chaos.
Because AI basically accelerates whatever you point it at. And if you aren't careful, that includes the production of catastrophic system failures.
Oh, 100%. Without a rigid framework, all that speed just means you are accumulating technical debt and broken systems way faster than a human could ever type them out.
Which is terrifying. So to give you a roadmap of where we're going, we are going to build this toolkit from the ground up today. Looking at how Git, command line interfaces, and continuous integration act as the ultimate safety net in the AI era.
And the foundation of that framework, the absolute non-negotiable baseline before you ever let an AI touch your code base, is Git. But we aren't talking about Git merely as a backup system. In the context of AI-assisted development, Git is your blast shield.
Your blast shield, I like that.
Yeah, because think about it as a distributed version control system. It's an offline first audit trail where every single change has an author, a date, and a message. You have a standard branch strategy separating your active development from your production-ready code.
So you aren't just pushing experiments live.
Exactly. Because when you prompt an AI to refactor, say, a complex authentication module, it might perfectly optimize your token parsing logic.
But then completely hallucinate the database query syntax.
Yes. It will confidently invent methods that do not even exist in your database library.
Which is just a visceral pain point for anyone working with these models, right? Like you get 1,000 lines of output, 800 lines are pure genius, and 200 lines are this subtle application-breaking garbage.
And that ratio is exactly why the presentation emphasizes the atomic commit principle.
Okay, let's break that down. The atomic commit principle. Basically, this is the practice of ensuring that one commit equals one strictly isolated logical change.
Right.
I always think of it, and maybe this could help you visualize it. It's like packing for a trip using packing cubes.
Oh, I like that analogy.
Right. If you put items into organized packing cubes, those are your atomic commits, it's super easy to pull out just your socks if you realize you packed the wrong ones.
Right, you just grab the cube with the socks.
Exactly. But if you throw everything into one giant lump, just a chaotic pile in your suitcase, what we sometimes call a lump commit, you have to empty the entire bag onto the bed just to fix one mistake.
And in code, treating version control like a giant dump truck, that carpet bombing approach, you are sweeping the brilliant AI logic and the hallucinated garbage into one single massive lump commit.
Which means when the pipeline inevitably breaks,
or a bug surfaces 3 days later.
Right. You're trapped.
Yeah.
You can't easily disentangle the good code from the bad. You end up having to rip out the entire module and start over.
Which totally negates the time you saved using the AI in the first place. But if you enforce atomic commits, you are executing surgical strikes. You isolate the AI's output into distinct logical units.
So you'd commit the token parsing logic first.
Yes, and then separately, you commit the database query changes. So when that hallucinated query syntax crashes the application, your blast radius is contained. Use a simple command to revert just the AI's mistake in seconds.
Git isn't just version control anymore. It's the ultimate undo button for AI hallucinations.
Exactly. You are compartmentalizing the AI's volatility locally.
Okay, so Git traps the code safely on our local machine. We have that hyper-specific rollback capability. But, that local safety net introduces a new bottleneck, doesn't it?
How do you mean?
Well, if the code is isolated locally, how do we efficiently push, review, and merge it? Especially if we're generating, dozens of these atomic commits an hour with AI.
Ah, right. Moving from the local Git repository to remote management is where the friction usually hits.
Right. And that's where the source material points to the CLI, specifically GitHub's official command line interface.
Yes. Because traditionally, developers have to switch context. They leave their code editor, open a browser, navigate to the repository, click through the pull request tabs, and start reviewing diffs in the UI.
It's a lot of steps.
It is. The GA CLI eliminates that entire sequence. You can check your workflow statuses with a simple grun list, you can dig into failure logs with grun view, and you manage pull requests with gpreall without ever leaving the terminal.
Okay, I have to play devil's advocate here, though.
Go for it.
Hold on, aren't web browsers and graphical interfaces supposed to make our lives easier? Like you can visualize branch topography, you read nicely formatted markdown, see inline comments clearly.
Sure.
Why are we retreating back into a text-only monochrome terminal window? Isn't that a step backward?
It's the classic UI versus CLI debate, right? But the calculus changes dramatically when you introduce AI.
Oh, so?
Well, there's a dual benefit. For the human developer, staying in the terminal prevents context switching. It keeps you in the zone.
Right, flow state is fragile.
Very.
Yeah.
But the crucial AI error reason, the real paradigm shift, AI agents don't use browsers.
Oh, wow.
Right? They don't have eyeballs, they don't click stylized merge buttons, and they definitely don't solve CAPI-TCAs.
They need an API to interact with the infrastructure.
Exactly. They need a programmable bridge. And G acts as that API bridge. It allows autonomous AI agents to operate GitHub programmatically.
So a text-based command line is actually the native dialect of an AI model.
You got it. And this allows power users to batch process commands. The presentation gives a great example of maintaining open source projects. Say you need to update a dependency across 21 different repositories.
Oh man, in a browser-based workflow, that is just a soul-crushing exercise in clicking. You open 21 tabs, wait for 21 pages to load, click merge 21 times.
It's like half an hour of mindless administrative labor.
But with eGUP acting as that API bridge, you just write a lightweight bash script, right?
Yeah, it iterates through an array of those 21 repos, executing gpre merge sequentially. What took 30 minutes in the browser executes in about 2 minutes in the terminal.
Because you bypass the visual rendering engine entirely. You combine human intent with machine execution speed.
Exactly. But, and there was a big but here, this brings us to the most critical failure point in the entire system.
Okay, so we've tracked the code in Git with surgical precision.
Yeah.
We've pushed it instantly using the CLI. Maximum velocity achieved. What's the problem?
The reality check. If an autonomous agent is firing off pull requests across 24 repositories in seconds, and we aren't manually reviewing every single line in a browser, how do we know the code isn't just completely broken?
Right, because AI models are notoriously confident. They will give you a beautifully documented function that completely crashes the moment it hits production.
Which is where continuous integration comes in. Specifically, GitHub Actions. CI is the automated safety net triggered by every single push.
Let me ask you this, though, and I think a lot of people wonder this. If an AI is smart enough to write complex software, it's trained on billions of lines of code. Why doesn't it just inherently know if the code works on a standard computer?
That's a great question. It's because AI is fundamentally platform blind.
Platform blind.
Yeah, its worldview is basically heavily biased toward Linux environments because that's where the vast majority of open source training data comes from.
Oh, right. But your end users aren't all in a Linux terminal.
Exactly. They are on Windows machines with totally different file path formatting. They're on Mac OS. They're running ARM processors instead of x86.
And the AI just assumes everyone is on Linux.
Pretty much. It will confidently write a file handling routine that works flawlessly on Ubuntu, but immediately throws a fatal exception on Windows.
So how does CI fix that?
By using something called matrix builds. Instead of just running one automated test, CI sets up a matrix. You take, say, 3 different operating systems, Windows, Mac, Linux, and multiply them by 2 different compiler configurations.
So that's 6 parallel builds.
Exactly. Instantly, every time code is pushed, the infrastructure spins up 6 distinct virtual machines. It tests the AI-generated code everywhere at once. It's the essential trust layer, hunting for the friction points the AI was blind to.
That makes so much sense. And the source outlines a really specific, typical dependency chain for how those matrix jobs execute, right? It's not a free-for-all.
No, it's a ruthless logical progression. Lint, build, test, and finally generate docs.
So it lints first, meaning it catches the obvious syntax errors.
Right, and if linting fails, the pipeline dies right there to save compute time. Why bother spinning up compilers for broken syntax?
Exactly. Then it builds across the matrix, then it runs the logical tests. And I found this last step brilliant. If it passes everything, the CI pipeline automatically triggers a tool to generate the updated documentation.
Like Doxygen, yeah.
Right. And it auto-deploys that documentation directly to a GitHub branch using an auto-injected secret token.
The secrets.ghub token. It's seamless. The developer doesn't have to juggle passwords or SSH keys. The pipeline authenticates itself.
You cannot trust the AI's raw output, but you can absolutely trust the pipeline.
Precisely. And to see how all these tools Git, the GA CLI and CI, actually harmonize to tame this AI speed development, we really need to look at the real-world example from the presentation.
Yes, the 5-minute dev loop. Let's walk through this because it turns theory into practice.
So imagine the developer makes a small push adjusting some syntax.
Step 1 and 2. The push is made. The developer checks GI run list in their terminal, and they see all 4 CI runners failed. Red X's across the board.
Now, the instinctive reflex for almost any human developer right now is to grab the mouse, open a browser, click into the failed run, and start scrolling through raw logs.
But they don't do that?
Nope. Step 3. They stick to the CLI. They type grunview to investigate the logs directly in the terminal.
And what they find is infuriatingly subtle.
It's always a tiny syntax thing, isn't it?
Oh, always. In this case, it was a Doxygen at verbatim tag.
Yeah.
It was accidentally left just outside of a required comment block.
And because it was outside the comment, the C++ compiler tried to read it as actual code.
Exactly. It read the @ symbol as a stray character, panicked, and crashed the build.
One stray character takes down the whole matrix.
Yep. So step 4 and 5, because the developer is already in the terminal, they just open the file, delete the orphaned line, a 1-line fix, and make an atomic commit.
They push it, which triggers the automated CI run again.
They verify it with G, and it's green across the board.
Yeah.
The incredible efficiency here is that this entire loop, from pushing bad code, catching the failure, finding the bug, fixing it, and getting a green light, it took under 5 minutes.
And no tabs were opened? No context was lost?
It's amazing. And it brings us to a perfect synthesis from the source, this productivity multiplier equation.
Oh, this is a great framing.
The equation is your actual output equals AI speed multiplied by CI safety multiplied by Git control.
It's basic math, right? In a multiplication problem, if any single variable is 0, the whole thing is 0.
Exactly. Without the safety of CI and the control of Git, infinite AI speed just creates a bigger mess. Your usable output is 0.
And that's the ultimate takeaway for you, the listener. Whether you are a seasoned open source maintainer or just someone managing automated workflows in your own industry, the lesson is universal. The faster your tools move, the stronger your foundation needs to be.
The influx of AI didn't render traditional version control obsolete. It made it the absolute most critical component. Which leaves us with a final, slightly provocative thought to mull over.
Oh, I like these.
Right. So, if AI continues to exponentially accelerate how fast code is generated, and these CI pipelines are doing all the matrix testing and verification, are human programmers destined to stop writing code entirely? Are we just evolving into full-time auditors and pipeline orchestrators?
Basically just watching the terminal matrix run while the machines write the actual logic.
Exactly.
Yeah.
It's a fundamental shift. Something to ponder the next time you find yourself reaching for the browser instead of the terminal. Thanks for joining us on this deep dive.
It's been great.
Catch you next time.